Cloud design and architecture. Cloud architecture refers to how various cloud technology components, such as hardware, virtual resources, software capabilities, and virtual network systems, interact and connect to create cloud computing environments. It acts as a blueprint that defines the best way to strategically combine resources to build a cloud environment for specific business needs. The integration of components into the cloud architecture determines how resources can be scaled, shared, and pooled via a network. It can be considered as a construction manual for deploying and running apps in cloud environments. The user interfaces, client-side apps, and client device or network that lets user communicate with and use cloud computing services are all included in front-end platforms in cloud computing. The cloud architecture part that makes up the cloud itself, such as computing resources, storage, security measures, management, and more, are referred to as the backend. In backend software or application, the client is accessing from the front end to coordinate or fulfill the client requests and requirements. Service is the heart of cloud architecture, taking care of all the tasks being run on a cloud computing system. It manages which resources you can access, including storage, application development environments, and web applications. Runtime Cloud provides the environment where services are run, acting as an operating system which handles the execution of service tasks and management. Storage component in the backend is where the data to operate applications is stored. While cloud storage options vary by providers, most cloud service providers offer flexible, scalable storage services which are designed to store and manage vast amounts of data in the cloud. Infrastructure is probably the most commonly known component of cloud architecture. It comprises of all the major hardware components that power cloud services, including the CPU, graphics processing units or GPU, network devices, and other hardware components needed for systems to run smoothly. Infrastructure also refers to all the software needed to run and manage everything. Cloud service models require that sources be managed in real time according to user requirements. It is essential to use management softwares, also known as middlewares, to coordinate communication between the backend and front end cloud architecture components and allocate resources for specific tasks. As more organizations continues to adopt cloud computing, implementing cloud security features and tools is critical to securing data, applications, and platforms. It is essential to plan and design data security, network security to provide visibility, prevent data loss and downtime, and ensure redundancy. This may include regular backups, debugging, and virtual firewalls. When an organization adopts cloud architecture, it frequently moves IT resources to public clouds, doing away with the need for on premises servers, storage, and power, and cooling requirements in favor of a monthly IT expense. There are three major models of cloud architecture that are driving organizations to the cloud. Each of these has its own benefits and key features. Software as a service. Providers distribute and manage softwares and applications to enterprises through the internet, doing away with the requirement for end users to install the software locally. Apps are often accessed using a web interface, which is essential from a wide range of hardware and operating systems. Platform as a service. A cloud computing approach where the service providers provides middleware and a computing platform as a service. On top of the platform, businesses can construct an application or service. While the end user manages software deployment and configuration settings, the cloud service provider supplies the network, servers, and storage needed to run an application. Infrastructure as a service. The most basic form of the cloud. A third party provider provides the required infrastructure so that the business don't have to buy servers, networks, or storage devices. Organizations in turn control their software and applications and only pay for the capacity that they really use. If we consider all of the elements of these major models as different layers that are stacked on top of one another, we can get a clearer grasp of how cloud architecture functions. The basic cloud architecture layers include the hardware layer, which has the servers, storage, network devices, and other hardware that power the cloud. Virtualization is an abstraction layer that creates a virtual representation of physical computing and storage resources. This allows multiple applications to use the same resource. Application and service layer coordinates and supports requests from front-end user interface offering different services based on the cloud service model. From resource allocation to application development tools to web-based applications. There are a few typical cloud architecture models, even though no two clouds are exactly the same. In a public cloud architecture, computing resources are owned and operated by cloud services providers. These resources are shared and redistributed across multiple tenants via the internet. Private cloud refers to a cloud that is owned and managed privately, usually in a company's own on premises data center. However, the private cloud can also span to include multiple server locations or leased space in geographically scattered co-location facilities. A hybrid cloud environment combines the operating efficiencies of the public cloud and the data security capabilities of the private cloud. Multiple cloud architecture uses multiple public cloud services. Multi-cloud architectures may be required to support microservices based containerized applications where services exist on multiple clouds. The fundamental components of cloud architecture mainly includes virtualization, where the clouds are built upon the virtualization of servers, storage, and networks. This abstraction layer enables multiple applications to utilize the same physical resources, thereby increasing the efficiency of server, storage, and networking through the enterprise. Infrastructure. The cloud infrastructure includes all the components of traditional data centers, including servers, persistent storage, and networking gear, including routers and switches. Middleware. As in traditional data centers, these software components, such as databases and communication applications, enable network computers, applications, and softwares to communicate with each other. Management tools enable to continuous monitoring of a cloud environment's performance and capacity. IT teams can track usage, deploy new apps, integrate data, and ensure disaster recovery all from a single console. Automation software. In cloud architecture, automation is used to easily scale up system resources to accommodate a spike in demand for compute power, deploy applications to meet fluctuating market demands, or ensure governance across a cloud environment. When compared to on premises settings, moving to the cloud can provide many businesses advantages, including increased agility and scalability, as well as cost effectiveness. While many businesses may initially adopt a lift and shift strategy in which existing on premises applications are transferred over with little to no modifications, it will eventually be necessary to build and deploy applications in accordance with the needs and specifications of cloud environment. Instead of investing upfront costs for servers, we can opt to use infrastructure of cloud service provider. We no longer need to wait to procure, set up, and configure computing infrastructure. Cloud architectures enable us to get up and running fast so that we can spend more time focuses on developing and delivering new products. Cloud architectures gives us more flexibility to scale computing resources up or down based on our infrastructure requirements. Cloud native architectures let us make the most of cloud or services and automated environments to speed up modernization and drive digital transformations. It allows us to leverage the latest technology for storage, security, analytics, and artificial intelligence like machine learning. Applications run and managed on cloud architectures benefit from high performance computing resources, which ensures continuous availability regardless of fluctuating loads. Lastly, cloud service providers consistently upgrade and improve their security mechanisms with expert professionals and the latest technologies to help secure our data systems and workloads.
All right. My name is Marco Gonzalez. I am a part of Team Guinea Pigs. And today I'm going to be talking about the future of cloud services and applications. A few things that I'm going to be touching on during my piece of the slideshow will mostly be around AI extensions, cloud computing, serverless computing, AR cloud, and different collaboration tools. Cool. So as far as AI extensions go, um, they're being developed every day. They're growing, especially now with ChatGPT. Of course, everything's kind of being built on the basis of the up and coming AI. But a few different AI tools that I wanted to just bring to everyone's attention are some that kind of go more into like different applications that we use now. I tried kind of leaning on things that pertain more to school since we're all in it. So one of the new ones that are coming out is one that's being brought specifically to Microsoft. So they're releasing an AI called Copilot. And it's going to be sitting mostly on Outlook, PowerPoint, Excel, and Word. Um, Not to be confused with Clippy, although a lot of people might not get that reference. But essentially, this Copilot is going to help introduce new features to users, and it'll be able to transcribe meeting notes during a Skype call, summarize long email threads to quickly draft suggested replies, request a you can request to create a specific chart in Excel, um, and you can easily turn Word documents into a PowerPoint presentation in seconds. So it's really just going to kind of help us expedite everything as far as creating documents and communication, which is pretty cool. As far as Chrome extensions, I definitely wanted to touch on a few um, different tools that kind of just help us day to day. Grammarly was a great one. I've actually been using that for a while, and it's gotten a lot better now that they use AI to kind of help you out. But for those who don't know what Grammarly is, it's essentially a cloud-based typing assistant, and it's powered by AI to improve your writing. Um, it does have a bunch of different plugins for Windows, for Chrome, iOS, and Android. So as we're writing our discussions, it'll basically tell you if you have any like errors, anything doesn't look good as far as like your sentences go. It'll kind of help you reword things in a way that makes a little more sense. So it's super helpful, especially when we're so used to just texting on our phones. We tend to kind of forget what the English language is supposed to look like. So Grammarly's been super helpful, and like I said, it has gotten a lot better now. Otter AI is another really useful one. So before Copilot comes out, you guys can give Otter AI a try. It does have paid versions, but it does have a free version that does a lot for you as well. So what's really cool about Otter AI is that you can actually sync it to your Google or your Microsoft Calendar, and it'll automatically join any meetings that you have. So for anybody that's taking online classes, I don't know about you guys, but for me, it's really hard to keep up, take notes, and still stay fully engaged without having to go back and rewatch some of those class meetings. But with Otter AI, it essentially automates your meeting notes for you. So it will essentially start taking notes for you. It can take screenshots of slides to kind of help organize everything for you. So it's something nice to have in the background. I still recommend taking notes, but for somebody that needs help taking notes, or just needs help having another set of notes in case you miss something while staying engaged and trying to talk with the instructor, this is a really good AI tool to have. Um, and then another one I just kind of wanted to bring up is Podcastle. Sounds a little bit boring up front. It's essentially a really good tool to just create podcasts with a lot of friendly, user-friendly tools, which is cool if you want to make podcasts. But the one thing that I did want to bring light to is their text-to-speech function. So what's really cool about this is that if you ever have an article, a chapter, or really just any text that you need to read, but don't really have time because you're on the move, their text to speech tool will use AI technology to convert any text into a podcast using voice skins. So you can listen to all of your text while you're driving, going for a run, exercising, or literally doing anything that you need to do, and it's free. So that's a really, really cool tool to have as far as AI extensions go. And of course, we can't leave ChatGPT out. It's growing. ChatGPT 4, I believe, is the new one. It's not really available unless you pay for it, but there is an extension for ChatGPT, so you can put that extension in your Google. So whenever you're Googling, it'll ask you if you want to view your ChatGPT results as well. I believe there's a few tutorials where you can actually embed ChatGPT into your Google searches too. So it'll just give you both your Google searches as well as your ChatGPT searches. So you just get more data, more information, which is a really helpful tool if you want to start utilizing AI in your everyday. So for the next one, we're going to be talking about cloud computing. So everybody kind of knows about cloud computing already as far as businesses go. But what I kind of wanted to focus a little bit more on is just personal cloud computing. Gaming is really, really big. Everyone's making their own computers, but um, for those who have built a gaming desktop or just a high performance desktop, we know how expensive that can be. So from a business standpoint, um, SaaS, PaaS, IaaS, all of those are really, really big as far as saving money. But it's nice that there's a lot of companies out there now who are bringing this to a more individual or personal platform. So one that I wanted to bring up is called Shadow. Um, they almost went out of business, but they did get bought out, so they're still alive. But this is essentially a personal computer that you can use, and it works on the cloud. It's really cool because they don't really require a lot of data on your end or a lot of performance on your end. So if you have a really old laptop, an iPad, a cell phone, you can use any of those things to run the system. Um, Really, all they ask for is 15 megabytes of download speed and less than 30 milliseconds of ping, which is recommended. But their system will essentially adapt to whatever available bandwidth you have. But this is cool. I use this just for gaming. I had an older laptop and I didn't really have the funds to buy a newer laptop or a gaming desktop. So I was able to run any video games I had on here. I know a lot of content creators that would use this just to edit videos or anything that just required a lot of power. You can run it on Windows, Mac OS, any Linux system. Like I said, you can run it on your Android phone, Raspberry Pi. If you have a Raspberry Pi laying around, you can just hook it up to your TV and you can run it on that. They just added like split or multi-screen as well, so you can stream on it if you want to stream too. But for someone that just needs a faster, higher performance computer and they don't really have the funds for it, this is a really good option. And it's gotten a lot better. They set it up for you in minutes to maybe like within the hour. A few other options I wanted to bring up is called shells.com. That one's affordable. You can use it every single day. A lot of small businesses can use it as well. And then another one is called Vagon.io. This one's really cool because if it's something that you don't need all the time, I really liked it. It's like $7 a month. And it's really just that's just to store any data so you don't lose your data. So if you want to like store files or games or anything on there, you can do that. And they have different stages. So one of like the base one, if you want to just like play video games, since that's kind of what I'm talking or talking about right now, it's 99 cents an hour. So if you want to just game for a few hours, I mean, even if you do 3 4 hours, that's $4 just to play whatever games you want. So it's not too bad. I mean, if you're going to be using it every single day, maybe not the best option, but it's there. And then we kind of move into serverless computing. So we did talk about this a little bit earlier already. So we touched on it with SAS and PaaS, but this is kind of the future. This is where everyone's going now. There is no need for running large server rooms or having another team that just does that. So we've already talked, at least in the class, about like AWS, Microsoft Azure, Google Cloud. Um, but you can essentially just build and run any application code without having to manage a server. So this is a really, really good way to save money. Um, it's very, very flexible to the user's needs. So this is really where businesses and programs and applications are kind of moving to. Um, it's made it a lot easier to develop, deploy, and scale applications. And I expect that this is pretty much where we're going to be going moving forward. Um, and here's our next one here. So AR Cloud. VR is has been around for a while. VR gaming has been around for a while, but AR's kind of it came and then it disappeared. I remember when AR first came out, like the one big thing they had was the Constellation application. I don't know if anybody remembers that, where you can kind of point it up at the sky and you can see all the constellations and stars and planets and all that stuff. And that's, at least for me, that's kind of where it ended for a while. And the reality is, it's just there really wasn't enough computational power um, within the user, right? So if we're running an application, you're using whatever you have in your hand. So in this case, with that app, it's your phone, and your phone just doesn't have that power. But with cloud being developed, with SaaS, PaaS, and IaaS being out there and being easily accessible, AR cloud can kind of boom a lot more. So for those who don't know what AR is, it's essentially the digital twin of the real world. If anyone's seen this movie here, this is a really really cool um, just visualization of what AR can be. So um, it's exploding a little bit more now with tools that you can use in conjunction with AR cloud. So, meaning the AR glasses, just like they use in this movie, headsets, gloves. There's a lot that's going to go in there depending on what you're trying to do with the AR, but it'll help you see something over the real world rather than VR, which is actually putting you in a completely different world. So, what can we do with AR? You can pretty much put this on anything. So, as far as something useful, you can use it for medical training. So, you can start practicing surgeries. You can actually do surgeries while being out of state. You can use it in retail. One really cool one that I wanted to bring up was Harley Davidson. They were one of the first to actually deploy AR within retail. So when they actually debuted it, you could use an iPad to go in a room and essentially look at an old rusted down bike. And then using the application, you can see what the restored version of that bike would look like. If you wanted to feel like Tony Stark, you can blow up the bike and you can actually look at all of the internal components. So you can see everything that's going into the bike. You can see how this could be really useful as far as like repair and maintenance goes. So if you're working in auto body, if you want to learn how to fix your own car, you can use AR to look at your car, look at the components. Using AI, you can use it to kind of help with diagnostics. You can use AI to help you find solutions. Which is going to be really useful in the future. You can use it to design and model pretty much anything from computers to houses to cars to infrastructure. I mean, the list goes on. But as far as cloud goes, we're essentially going to be able to make AR more accessible and scalable. And that's going to lead me to our last slide here, which is collaboration tools, and we've kind of talked about it a little bit already. Um, Everybody uses them. AI is being introduced into them. One collaboration tool I wanted to bring up is called Sharp Cloud. Not so much for us, but it's more for business. It's essentially a business collaboration tool. So it's going to transform business data into visual stories that make it easier to digest. When I worked in corporate, I found this very useful because we had something very similar to this. I had access to a few different websites that just gave us a lot of data within the business, and it was really hard for me to understand. So once they switched to a completely new system, it just turned everything into visuals. I had more graphs, pie charts, and it just kind of helped to break everything down. So that's very useful here as far as collaboration tools go and sharing data within a business. But more down to us into school, we can look at Office 365. We can see how Microsoft completely switched over to this to just make it a bit more streamlined, a bit more accessible, so that you don't just have it on one application. You can use it on anything you have, whether it's your iPad, different computer, school computer, home computer. You can look at Google Suite and how easily it is to share any of the documents that you have within Excel or Sheets, PowerPoint, slides, Word, Docs, and you can just kind of collaborate with classmates, teammates, just like we did with this project here. We use Google Suite, and I was able to share the slides so that everybody can just collaborate, put all our slides together, and this is how we're going to kind of put the whole project together. Uh, to go a little bit deeper into coding, we can look at cloud IDEs. You don't have to be in the same room with your team anymore. So if you are working on designing or putting together an application or code, the whole team can now work on a cloud IDE, and everybody can kind of collaborate in real time. You can see what everybody's working on, what they did in the past, what they're doing or now or in the future, and you can kind of work together to get everything working. And then, of course, we can just kind of talk about communication in general, like Teams, Slack, Zoom, stuff like that. But that's pretty much going to end it for me, and I'm going to pass it on to the next teammate. Thanks.
Welcome to Guinea Pigs Future of Tech, the podcast where we explore the most exciting developments in the world of technology. I'm your host, Ina Tsigankova. In today's episode, we'll predict the future of cloud computing, taking you on a journey through some of its most groundbreaking aspects. We'll be diving into edge computing, serverless computing, quantum computing, and AI powered gaming. So fasten your seatbelts and join us as we delve into the fascinating world of cloud computing and its potential to reshape our lives. Let's get started. Edge computing is an exciting concept that's transforming the way we interact with technology. In a nutshell, it refers to the processing of data closer to its source, rather than relying on centralized data centers. This enables real time processing, reduced latency, and improved efficiency, making it an essential component of our increasingly connected world. As we look into the future, we can expect four key trends to shape the evolution of edge computing: greater adoption, integration with 5G, enhanced focus on security, and advances in hardware. First, let's talk about greater adoption. As the Internet of Things continues to grow, more devices are generating and processing data at the edge. Industries like manufacturing, healthcare, and transportation are already leveraging edge computing to optimize their operations. We can expect to see more sectors joining the fray as the benefits of edge computing become increasingly evident. Next, we have the integration with 5G. The rollout of 5G network is set to be a game changer for edge computing. With its ultra low latency and high speed connectivity, 5G is poised to fuel the growth of edge computing by enabling real time data processing for applications like autonomous vehicles, smart cities, and virtual reality. As 5G networks expand, we'll witness a deeper integration between the two technologies, unlocking new possibilities and use cases. Security is always a top priority, and edge computing is no exception. With more devices and data at the edge, it's crucial to address potential vulnerabilities and protect sensitive information. We could expect a greater focus on security measures like data encryption, access control, and security communication protocols. This will ensure that edge computing remains a reliable and trusted solution for businesses and individuals alike. Finally, we have advances in hardware. To support the growing demands of edge computing, hardware must evolve. We need the development of more powerful, energy efficient processors optimized for edge environments. These advances will enable edge devices to handle increasingly complex tasks, opening up even more opportunities for innovation. In conclusion, the edge computing future is really bright as we witness greater adoption across industries and integration with 5G, heightened focus on security, and advances in hardware. Edge computing will continue to transform the way we live and work. It is an exciting time for technology enthusiasts and professionals alike as we embrace the potential of cutting edge approaches in computing. Moving on to another groundbreaking area of technology, let's take a look at the future of quantum computing. This revolutionary field has the potential to completely reshape computing as we know it. Quantum computing is a form of computing that harnesses the principles of quantum mechanics to perform complex calculations. Unlike classical computers that use bits to represent data as zeros or ones, quantum computers use quantum bits or qubits, which can represent both zeros and ones simultaneously. This unique property enables quantum computers to solve problems that are currently still very difficult for classical computers to solve. As we look ahead, we can expect four key developments in quantum computing: increased scalability, more powerful algorithms, quantum networking, and quantum machine learning. First up is increased scalability. Today's quantum computers are still in their infancy, with a limited number of qubits. However, researchers are working tirelessly to develop more scalable systems, capable of handling more qubits and performing more complex calculations. As quantum computers become more scalable, their potential applications will expand, paving the way for groundbreaking advances in fields like cryptography, drug discovery, and optimization problems. Next, we have powerful algorithms. As the capabilities of quantum computers grow, researchers will develop increasingly sophisticated algorithms that harness the full power of quantum computing. These algorithms will enable us to tackle previously unsolvable problems, opening up a new adventure and new avenues of researchers and research and innovation across various domains. Third is the development of quantum networking. Quantum networking refers to the establishment of secure communication channels between quantum devices, enabling the principle of quantum mechanics. This technology has the potential to revolutionize secure communication and pave the way for the creation of quantum internet, which would offer unparalleled levels of security and performance. Finally, we have quantum machine learning. Machine learning is a subnet of artificial intelligence, has already transformed numerous industries. By integrating quantum computing into machine learning, we can develop even more powerful models capable of solving complex problems faster and more efficiently. This fusion of technologies could lead to breakthroughs in areas like computer versions, processing, language processing, and predictive analytics. The future of quantum computing holds immense promise. With increased scalability, more powerful algorithms, quantum networking, and quantum machine learning, we are on the cusp of a new era in computing. As these advancements become a reality, we can expect quantum computing to have a profound impact on our world, revolutionizing industries and driving innovation like never before. That wraps up our discussion on the future of quantum computing. Let's turn our attention to yet another transformative technology, serverless computing. This innovative approach to computing has been gaining traction in recent years, and it's poised to continue reshaping the way we build and deploy applications. In a nutshell, serverless computing is a cloud computing model where the cloud provider manages the underlying infrastructure, dynamically allocating resources as needed. This allows developers to focus solely on writing code without having to worry about server management or capacity planning. Serverless computing automatically scales with demand, making it an ideal solution for applications with fluctuating workloads. As we peer into the future of serverless computing, we can anticipate four key trends: continued growth in adoption, integration with other cloud services, increased focus on security, and advancement in performance and latency. First, let's discuss continued growth in adoption. Serverless computing has already made significant inroads, particularly for startups and companies looking for optimized cost and streamline operations. As more organizations become aware of the benefits of serverless computing, we can expect its adoption to continue to grow. This growth will be driven by the need for scalability, flexibility, and cost effectiveness in application development and deployment. Next, we have integration with other cloud services. As serverless computing matures, it's likely to become more deeply integrated with other cloud service and platforms. This would enable seamless interoperability between various cloud based tools and services, creating a more cohesive and effective and effective development ecosystem. Developers will be able to harness the full power of the cloud, leveraging serverless computing in tandem with other services like machine learning and data storage and analytics. Now, let's talk a little bit about increased focus on security. As serverless computing becomes more popular, ensuring the security of applications and data will become even more crucial. We can anticipate cloud providers and developers alike placing a greater emphasis on implementing robust security measures, including data encryption, access control, secure communication protocols, and other security controls. This will ensure that serverless computing remains a trusted and secure solution for organizations of all sizes. Lastly, we have advancement in performance and latency. While serverless computing offers many advantages, it can sometimes be um, suffering from performance limitations and increased latency due to its dynamic nature. However, as the technology evolves, we can expect improvements in those areas. Cloud providers will likely invest in optimizing their serverless platforms, reducing latency, and enhancing performance. This will make serverless computing an even more attractive option for a broader range of applications and use cases. The future of serverless computing looks pretty bright as we see continued growth in adoption, deeper integration with other cloud services, a heightened focus on security, and advancement in performance and latency. Serverless computers will continue to transform the way we build and deploy applications. It's an exciting time for developers and organizations looking to harness the power of the cloud and stay ahead of the curve. And that concludes our exploration of the future of serverless computing. Let's dive into an area that's near and dear to many of our hearts: gaming. Specifically, let's explore the future of AI powered gaming and how artificial intelligence is set to revolutionize our gaming experience. AI powered gaming refers to the integration of artificial intelligence technologies into video games. This can manifest in various ways, from creating a more lifelike characters and environments to generating personalized experiences that are tailored to individual players. With AI playing a bigger role in gaming, we can expect four major developments: more realistic game characters and environments, personalized game experiences, enhanced game mechanisms, and the emergence of new game genres. First, let's talk about more realistic game characters and environments. AI technologies such as machine learning and natural language processing can be used to create a more believable and complex characters in games. This means that non-player characters will be able to interact with players more naturally, adapting to their behavior, dialogues, and base it off of the player's actions. Additionally, AI will be used to generate more immersive dynamic environments where elements like weather, wildlife, and even entire ecosystems can evolve and change over time. Next, we have personalized game experiences. AI can be used to analyze a player's preferences, play styles, and skill levels, enabling the game to adjust its difficulty, pacing, and content accordingly. This results in a more engaging and customized experience, making each playthrough unique and tailored to the individual player. Now let's discuss enhanced game mechanisms. This can improve various aspects of gameplay, such as pathfinding, decision making, and enemy behavior. This can lead to more challenging and dynamic gameplay, as AI powered enemies adapt to the player's strategies and learn from their actions. Additionally, AI can be used to refine and optimize game mechanics, ensuring that games are more balanced and enjoyable. Lastly, we can expect the emergence of new game genres. As AI continues to evolve, it will unlock new possibilities for game development, leading to a creation of entirely new genres in gaming experiences. This could range from AI driven storytelling experiences to games that seamlessly blend virtual and real world environments. The future of AI powered gaming is filled with exciting possibilities. As artificial intelligence become more integrated into the gaming industry, we will see more realistic characters and environments, personalized experiences, and enhanced game mechanics, and the emergence of new game genres. It's an exciting time to be a gamer, and we will witness the dawn of a new era in interactive entertainment. That's it for today's episode of Guinea Pigs Future Tech. Thank you for joining us as we explore the future of AI powered gaming. Be sure to tune in next time when the next speaker will talk about the future of cloud security.
Hello, good morning, good evening, good afternoon. My name is Derek Judge, and I'm going to be talking about the future of cloud security. So, just to get the definition down, cloud security would be the way in which cloud providers deal with internal and external threats. So, cloud services generally have a lot of procedures that they follow, and cloud security, like any other security, is extremely important because oftentimes cloud services in terms of data are holding potentially very important data for a lot of companies. And you need very strong cloud security in order to protect that data. So let's move on now to confidential computing. All right, so confidential computing. So confidential computing is what I think will be one of the biggest things in terms of the future of cloud security. So confidential computing essentially is isolating sensitive data into a part of the CPU, and only the client will have access to that part, and it will even be invisible to the cloud provider itself. So in confidential computing, it is client only access, which is a huge part of why I think this is going to be the future. The data is encrypted and only the client has the key to that data. And I think that there's a big concern for a lot of companies in terms of data residency, where the data is held. If it's held out of country, you wouldn't really want to go with that cloud provider. But now with confidential computing, you can do that. So it brings that trust to the cloud service provider in any company that was teetering back and forth can now partake in cloud services because now all their data is not even knowable to the cloud provider itself. And next up, we have biometric scanning. So biometric scanning is essentially using a part of your biology, right? Your eyes, your fingerprints, or your face, for example, to get past a security point. And this is what I think will be the future of the physical component of cloud security. So the reason why I think this may not be as quick, though, as confidential computing is because it is a bit more expensive and more to manage than it is just essentially swiping a card, because nowadays you have security cards, and that's mostly what you're going to use for accessing a lot of security points. But I think biometric scanning can be used, maybe not on the not as sensitive data, but the more sensitive data it is, I think companies will implement biometric security scanners for those more secure areas because they are more expensive, but it is better to use biometric security scanners to protect your more sensitive data. So the zero trust model. Actually, when I was reading up on this, I was surprised that it wasn't already the most implemented model for permissions in terms of an organization. But the zero trust model is essentially every user is verified. So even if you sign into the corporate LAN or you've been previously verified and you've been previously had these permissions, you need to verify yourself every single time. And I think that's a great procedure and model and policy to go by in terms of, your access control lists and everything like that. I think the zero trust model is the absolute future model for cloud security. And I don't understand how it wasn't already implemented, but I believe that this is the future. Lastly is the multi-cloud architecture. So a multi-cloud architecture is when a company uses multiple services from multiple different cloud providers. And I think this is going to be the future because I think a lot of companies nowadays they find one cloud provider that they like and they go with that one cloud provider with the many services that they have. And I'm not saying that's a bad thing, but I think that it's not as optimal or as good as a multi-cloud architecture, because with a multi-cloud architecture, you can spread your workload across multiple different clouds, not putting pressure on just one cloud. That's why this increases the availability and the resilience of each one, because your workload is spread. And you also get better provider selection. Maybe one cloud does this better. One cloud has these features that you like more as a company, and another cloud has this. Better licensing models here, better licensing model there, and also migration, which is very important, so you don't get stuck in one cloud. Not every cloud has maybe the migration of the data that you want, so maybe you don't put as much sensitive data into that company. That's why I think this model will probably be the defining model of cloud architecture for the future of cloud security.